Hey everybody, this video is to go over how to solve a rational equation, which are the type of equations you see on the screen. They are equations with fractions. And so the first thing you need to know to be able to solve a rational equation is just like when you're adding and subtracting fractions back in elementary school, you have to have a common denominator. Once you have a common denominator, you can just drop them. So in number 7, I have a common denominator already, 2x minus 5 all the way across. So I'm just going to solve this equation as 14 plus 7x is equal to 63. Because if all the bottoms are equal, then the numerators also need to be equal. So I would subtract 14. This would give me 7x is equal to, what's that, 49? And then I would divide by 7, and that leaves me with 7. One thing you need to be aware of when doing these types of problems is making sure your solution is not restricted. So what would be restricted would be what would make this denominator be 0. That would end up being 5 halves. You could find your restricted value by doing 2x minus 5 is equal to 0. You would add 5, divide by 2, and that would be 5 halves. So since our answer is not 5 halves, then we know it's not that restricted value and it's not extraneous. Is what we call it, is the extraneous solution. You can easily check these by going to your calculator and doing y equals the left and y equals the right side of the equation. So I would do y is equal to, the fraction was 2x plus 5, or was it minus 5? All right, it was minus 5. And I think it was 7 plus the fraction of 2x minus 5 and 7x and 63. If this was 14. 14, 7x, and then I'll go down here and do y equals 63 over 2x minus 5. And the answer is where they intersect. And if I type that, click that dot, the answer would be 7. The other way we can check any equation is just by plugging in for the x value. So I could plug in here. I would just change this to parentheses 7. And then also over here, parentheses 7. I'm just plugging in what I got for x. And that also checks my answer. So I plugged it into the left side of the equation, I plugged it into the right side of the equation, and I made sure that those are the same values. So you could also do it that way in a standard calculator or a TI-84 also. All right, so number 8 here does not have a common denominator, so I am going to start by factoring the x squared minus 4x minus 12, this denominator right here. And typically I tell my students to look for the other denominators because those might be your factors. Sometimes you can use the problem to do the problem. So if I would have 2 over x minus 6 plus 7 over x plus 2, let's see if we factor this. If I use x minus 6 times x plus 2, that multiplies to be negative 12 on the end and adds to be the negative 4 in the middle. So that is the correct denominator. But we need to get the other two denominators to also be x minus 6 times x plus 2. So I'm going to multiply this fraction by x plus 2 top and bottom, because anytime you multiply something on the top and on the bottom, it's like you did nothing at all. It keeps it equivalent. And so I'll multiply the other fraction by x minus 6 top and bottom. And now all three denominators are x plus 2 and x minus 6. Doesn't matter the order. So they all have the same factors on the bottom. We can now drop the denominators. I'm going to rewrite this as 2 times x plus 2. I just put the 2 in the front. It's the same thing. Then I have plus 7 times x minus 6 is equal to 4x plus 2. I am going to distribute the numbers into the parentheses. So 2 times x is 2x, 2 times 2 is 4, 7 times x is 7x. 7 times negative 6 is negative 42, and it's equal to 4x plus 2. I'm going to combine my like terms to make 9x. 4 take away 42 is negative 38. I move smaller variables first, so I'm going to subtract 4x, but that's not the only option. Then I would add the 38 to give me 40 and divide by 5 to give me 8. Now, I want to make sure that's not a restricted value, and a restricted value, again, is what would make the denominators be 0. And so the two restricted values are that x is not allowed to be -2 and x is not allowed to be +6, because those two values would make your factors in the denominator be 0, and you'd be dividing by 0, which is not allowed. But you could check this problem by plugging back in. All right. Let's look at number 9 here. We have r over r plus 2 and then 8 over r squared minus 4. So I'm going to make this be r over r plus 2. I'm going to keep it the same for now. And then I'm going to factor r squared minus 4. R squared minus 4 is the difference of squares. That's r plus 2 times r minus 2. And then I see that the only thing I need to change about the one on the left is that it doesn't have a r minus 2. So I'm going to multiply it top and bottom by r minus 2. Now both fractions have the same denominator and I can drop them. You're also allowed to cross multiply on number 9 because there's no addition or subtraction between fractions happening. It's just a fraction equals a fraction. So you can solve it like a proportion. But I have r times r minus 2 from the top is equal to 8. I'm going to distribute. That gives me r squared minus 2r is equal to 8. When you see a term squared, let's clear out these. We don't need them. When I see that r squared term, I'm going to get it equal to 0 because it's a quadratic equation. And then I did that by moving the 8 over and making it negative. And now I'm going to factor that. I want it to multiply to be -8 and add to be -2. So if I do r take away 4 and r plus 2, that adds to be multiplies to be -8 and adds to be -2 in the middle. So my solutions are r equals 4 and r equals -2. Now when I go back up and think about my restricted values for this problem, x is not allowed to be 2 and x is not allowed to be -2 because either of those would make these denominators be 0, and then you would be dividing by 0, which is a problem. It's undefined there. So it's undefined at -2, so we call this extraneous, and so it's not really a solution. It does not mean that you did the problem wrong. It just means that that value doesn't actually work. When you plug it back in, it makes it undefined. All right, one more example. For number 10 here, we have 4 over x minus 2, and then we have 10 over x squared minus 4x plus 4, and then we have 6 over 1. I like to write a 1 when there's no denominator there to remind me that it still needs a common denominator. I'm going to leave the 4 over x minus 2 alone for now, and I'm going to factor the second denominator. I'm going to try to use that x minus 2 because that typically is a hint. And x minus 2 times x minus 2 would multiply to be the +4 and add to be the -4 in the middle. And then I still have 6 over 1. So I need to multiply top and bottom to all these fractions to get a common denominator. So I'm going to multiply this first one by x plus 2 top and bottom. Oops, not x plus 2. What am I doing? Thinking about the last problem. X minus 2 top and bottom. So now those are both x minus 2, x minus 2. And then this last fraction needs x minus 2 times x minus 2. All right, so now I have the same denominator all across. I'm going to drop my denominators. I have 4 times x minus 2 from the first fraction. I have plus 10 from the second fraction. In the third fraction, I have 6 times x minus 2 times x minus 2. Now, we know what x minus 2 times x minus 2 is. It's this trinomial right there. We just factored it. So I'm just going to go ahead and write it down like that to make my life easier. Just redistribute it back. And then I'm going to distribute my 4 and distribute my 6. and I see that this is a quadratic equation. I can tell that because I have x squared term. So since it's quadratic and everything on the right side is what I'm dealing with that's quadratic here, I am going to move everything else to the right side. So first, I know that these two things are positive 2, so I'm just going to subtract 2 from both sides to get that to go away. Really, that's positive 2. So I'm subtracting 2. I could just go ahead and combine these and not be lazy. That way you can see my steps more clearly. So I'm taking the 2 away, and I'm going to take away the 4x. So now we have 0 is equal to 6x squared minus 28x plus 22. All right, so we would want to try at this point to factor this quadratic equation. This one is a little more challenging to factor because there is a 6 in the front, but it is not impossible. And so what I do is I first look for a GCF. I know all 3 of these things are divisible by 2, so I can pull out a 2 and make the numbers smaller. That would become 3x squared, and then it would become minus 14x plus 11. So now I'm going to use the divide and slide method. I have a video on this if you're not used to it. I love it. So this would be A, this is C. I do A times C is equal to 33. I need it to add to equal negative 14. And so the two numbers that multiply to be 33 and add to be 14 are 3 and 11. If I make them both negative, it gives me a negative 14, but it still multiplies to be a positive 33. So I have my factors are going to be x minus 3 and x minus 11. With the divide and slide method, you divide by a. So I'm going to divide by a, divide by a. If I can simplify, I do. 3 over 3 is 1. And this cannot be simplified, so this is 3x minus 11. I slide it into the front. The 2 is still there, but we don't really need it. So then my solutions are 1 and 11 over 3. I did graph this in Desmos, so we did factor this correctly. And I want to check to make sure those are not restricted values. My restricted values for this problem would have just been 2. Neither of those is 2, and so those are both my answers. So definitely a more challenging example there.